Um, Today we have our final Tech Bites of the quarter, and with us we have Jeremy Nelson, who is the Metadata and Systems Librarian at Colorado College. He is also an adjunct faculty here at DU, currently teaching the Intro to Library Systems class, and he is going to be talking about the library as a lean startup. I will give it to him.
Thank you, Chris. All right, so in case you want to go back and look at some of my notes and everything, this presentation is actually a website that's hosted off of our Intro to Libsys class website. So it's at introdolibsys.info/techbytes. So I'll be going through a lot of different things, and don't worry if you might not catch anything. You can always go back, and there's also a glossary and a resources page as well. So I'm going to start this and kind of talk about an organizational model for libraries that was actually first introduced to a couple of weeks ago at a leadership institute I was at, because I think it provides a good conceptual model of a typical organizational structure of a library. And I'll use that sort of model then to talk about how startups, in particular a type of startup called Lean Startup, some of their techniques, methodologies, technologies are really exciting and can be applied to a library. And then we'll go into really the meat of some of the research and some of the things I've been doing at Colorado College in using some more of these startup, if you will, technologies that are really not being used at all in our current vendors or our current library industry. So to start off with, I want to talk about this organizational map. And this organizational map comes from Pat Wagner of Pattern Research. And she breaks it down into 3 different levels of where people put themselves in a typical library or even a typical organization. So the bottom level is the task level. And the task level is very much what we think of as the day-to-day work. So for example, a task level activity may be the reference librarian at a service desk going through a reference desk and interacting with a patron who comes in with a reference in. That's very specific. It's very task-oriented. You have the task of doing that. It's easily trackable, and you can actually see the results quickly. Or a cataloger cataloging 30 or 40 objects in a workday would be another example of a task-based level. So this is where most our work, and if we think of work really broadly in a library, is done, is at the task level. When we start going up the level to the next level, the managerial level, this is where your manager of reference services, for example, coordinates the work being done, coordinates the tasks, communicates with the people involved at the task level, and also up at the top level, the leadership level. So kind of the middle management layer. And Pat calls that the managerial level. And so each of the levels has a different set of skills and different expectations. And what I really kind of got out of it is it's really time related. So at a managerial level, they're concerned at the most 2 years out of whatever they're managing. So they're not as concerned with the large strategic direction necessarily of the library. The top level is the leadership level, and there we think of our library director. This is the person who, typically a single person, but it could be multiple people. At a larger institution, you might have a leadership council or a dean council or whatever, and they're more concerned about having a vision of where they want to see the library over a long term. They're also, it's really important at the leadership level to be able to communicate effectively and to be able to influence not only their internal constituents, but a real job of a leader, of a library director, is to influence external parties to the library. So for an academic library, that may mean talking with the dean, interacting with the dean. Public libraries, and you may have a library council or the town council, for example, may be an example of an external body that you as a leadership person must be able to influence to get what you want to fulfill your grand vision. There's also at the leadership level more of a risk. Because of leadership, you're looking at more than a couple years out. You're looking at long-term strategies, long-term decisions. Those decisions may not be immediately apparent to the other levels within the library. So the managerial level, or definitely the task level, a decision to go with a new ILS at the leadership level may not immediately be reflected in the cataloger's day-to-day work, for example. So that idea of this time component is real critical to her organizational model. And so you can hear, so here's a little bit of a diagram I think that helps to kind of picture what's going on here. So now is the point in time. This is where at the task level you're primarily concerned about. You're primarily concerned about completing your task within maybe a week, if you will. Then as we go up further to the levels, to the managerial level, we can see the manager usually has a longer time span what they're concerned with. So they may have goals that they want at the task level to fulfill, those specific actions, if you hear. Then as we go further to the leadership level, there the sort of visions of where the library director wants the library to go. Clearly that's pretty far out in the future, and it doesn't impact these other layers as much. So technology and library systems in particular, I think it's important to consider that your systems impact all these different layers, and these different layers have different requirements that the technology you're evaluating or using needs to meet or fulfill. So in the traditional process, an evaluation process for example, for a new integrated library system, hopefully that's composed of that group of representatives from each of the layers, if you will, or levels. However, oftentimes that's not the case. You might just have the leadership and managerial levels deciding that, hey, this ILS meets our vision, meets these goals, but when it comes to actually do the action or task, it may be impossible, or it may actually be impossible at this level, or really difficult at this level. And so if problems occur here, that's going to impact the goals, and that's going to impact the vision. And so that's where we have ineffective leadership and ineffective management, when the actions aren't being reflected through the goals to the ultimate vision of the library. So that's sort of the model of librarian operations that we'll go from. So like I mentioned before, there are implications for library technology. Also another thing that's important, that there's not just the actual workflows that a typical library system supports. There also needs to be sort of a reporting function as well. And the reporting function serves more the needs of the managerial and leadership levels. And so that's an example of a specific aspect of technology that needs to be met by whatever system you're evaluating or looking at. So I'm going to go next and talk about lean startups, and startups in particular. And there's some, so while the Silicon Valley, I think, is justifiably famous for its startup and entrepreneurial culture, I think really libraries and library systems in particular, we can improve our own technology and our services by adopting some of these principles and our own organizational structures and practices. So one common aspect in most modern startups is the idea of using agile software development. So agile software development is different than the opposite, or waterfall software development, in that you're looking to create some sort of usable software in a short amount of time and then iteratively test it over time, getting the actual end user community that's using the product to to participate actively in the development process. This means that you're not going to have perfect software immediately. It doesn't mean that you're going to end up at the greatest system in the world. What it's really looking at doing is trying to solve a problem in the immediate term. It's not looking at the long term in terms of a long horizon. The agile model of development has been very successful for a lot of startups that have eventually become into some of the largest companies you know of. Google, I think at the beginning, used some agile techniques. Facebook uses agile techniques, going all the way down to a lot of the startups that are producing apps for the iPhone or Android. Also, to create their apps, they're using this agile development model. So, kind of given that structure, the idea of a lean startup is to use this agile development process and to create something immediately, get it out the door, and the goal of a lean startup is not necessarily to go out and search for venture capital funding. The idea is that if you're lean enough, and if you're able to use more cloud-based storage and cloud-based services, you can have a really short iterative development cycle. So some of these principles of a lean startup is that you learn often, you fail fast, and get out of the building. That last part means, don't spend 80, 90 hours coding. Get out there, have a life outside of software development. Fake it before you can make it. Well, if you can show something, even though it may not work perfectly, that's better than having nothing at all. So another kind of related to that is starting small. So you may have a small prototype of a product or service, and then once it's established, once people start using it, then look at trying to scale that up. Keep iterating. That's very important. So the short iteration cycles means that your user is constantly testing the changes you're making to meet their requirements. MVP is minimal viable product. That's what that stands for. And it should just be, they say minimally awesome. So don't try to go for the moon with that. Just make it minimally viable to meet the needs of your end user. And then the final one is the web is your lab. So most web-based or network-based software, websites, apps, you can use that network, the fact that it's out there, to continually test like new features or requirements that you're trying to test. So what has happened also in the past couple of years is the growing recognition in particularly large organizations that may not necessarily be a software company, but have a large technological component, which in fact I think is most organizations now, is to see what kind of lessons they can take from this agile, lean startup and apply it to a corporate IT environment or a large library systems environment, the same sort of processes. And so, so this is called DevOps, which is an amalgamation of development and operations. So the idea is that a lot of times an IT group will create or modify or customize existing software or create some lightweight custom solutions to meet the business needs or requirements of a larger organization. And then that gets turned over to a whole separate group of operations that's to maintain the actual service itself. What has happened over time is that there's been a divergence between those two groups. And in fact, it's difficult to get something out of development into this production or operations. So this idea in this DevOps movement is to combine the two groups and to use agile management processes to quickly respond to requirements from the organization's users, as well as develop custom code. Because really, it's very rare that a large enterprise system will fulfill all your needs right out of the box. In fact, most of the times it requires a lot of customization. And so this gives more of a structure for that sort of work. So before we leave, there is a question now, when I'm talking about startups, I'm talking about libraries, well, what about library startups? And we've actually seen more in the larger ILS market, there's actually been a consolidation, so there's not that much startup activity. What's kind of exciting is in some of the other library technology related field. Media Shelf and Discovery Garden are two startups that are doing quite well in the digital repository. Our industry, I don't want to say it's a complete industry, but that subset of library technology. Discovery Garden supports a custom Drupal interface to Fedora called Islandora. Media Shelf is basically the equivalent in Ruby on Rails and Blacklight for Fedora Commons. So they're both startups. There's also been a lot of startup activity in more of the semantic web. And we'd really, as librarians or future librarians, we may not hear about the semantic web as much, but I think there's a lot of openings for our particular skill sets in the semantic web. So there is also a lot of startup activity in more general the semantic web. So now we're going to talk about Ferber, RDA, and MARC-R. So I hope you're kind of familiar. We'll go through these really quickly. So Ferber stands for the Functional Requirements for Bibliographic Records. It is actually a pretty old, it first came out in 1998 as an entity relationship model where the objects of interest called entities are defined in a general way, and then you associate properties and relationships with other entities. So this is from Wikipedia, where you have 4 different of these basic Ferber entities. Your work is your most abstract. Then as you become more concrete, you go to expression, manifestation, and item. So the reason I bring up Ferber is because Ferber is really one of the core bibliographic ideas that RDA, which is the next, click here, which is RDA uses to replace AACR2. So these are, RDA is a set of cataloging rules that's very much still in development that is based on Ferber and not on the sort of MARC pseudo model that's out there. Finally, MARC-R. So this is actually really new. So the Library of Congress, back last fall, they created a Bibliographic Frameworks Initiative work group, and they've been doing, their big charge is to replace MARC 21 and seeing how can we enable library systems to better represent the explosion of digital objects that has occurred since MARC 21 was originated in the late 60s. So this comes from actually a slide by Sally McCollum, who's part of that group. And this is their new model that they call MARC-R. So they have used and is heavily influenced by Ferber and RDA, but they've actually simplified it quite a bit. And in fact, this makes it easier to implement than to try to implement a native Ferber system. So you have this idea of a work still. A work is abstract. It's not something that actually exists. But then you only have one other layer of the opposite of abstraction, concreteness, if you will, called an instance. And an instance refers to the specific item or digital surrogate that's available. And there are each of these has annotations and authorities. So authority entities, are subject and author and creator authorities that we have in MARC. And those are entities that are associated with the work. The instance has these different types of annotations. So we have, for example, a publisher annotation, or in this case, this might be an authority. Another annotation might be like a table of contents that adds a little bit more to the work or the instance. So this newer model, they've collectively called it MARC-R for MARC resources. There's a link here to her presentation if you want to learn a little bit more. MARC-R, so the concepts and these relations come from this idea of linked data. Now, linked data really quickly is a way to associate entities with each other on the web, most broadly. We can go in more detail maybe at some other point, but this whole linked data movement really influenced the MARC-R effort. So on to the next slide. So how are we using MARC-R at Colorado College? And we're able to do that because we've adopted one of the technologies, data store technologies that's being used in the startup world pretty effectively. So in case you're not familiar, NoSQL and cloud computing are very interrelated. So NoSQL is just a general term for a whole class of different data store technologies that are not based on a relational database design. You can have different types of NoSQL technologies. Probably the most famous that's being really well used is a spin-off or an open source implementation of Google's big table algorithm called Hadoop. And Hadoop is really used in big data analytics and big data crunching. Other NoSQL technologies, Cassandra from Facebook is similar to Hadoop. Then there's also more documented-oriented data stores, like MongoDB, CouchDB, and Amazon SimpleDB. So not all of these NoSQL technologies are open source. For example, Amazon's infrastructure, or SimpleDB, is definitely not open source. But it is being used by a lot of these startups. And a lot of these different types of NoSQL technologies lend themselves really easy to run on either public clouds, so external server environments, internal server environments, or like hybrid environments. So one of those NoSQL technologies I've really started using and really enjoy, I think it's really great, is called Redis. And so Redis is a key value data store that resides completely in the computer's memory, so you're not going back and forth to the disk to retrieve information. What's really cool about Redis is that it has a whole set of data primitives that you can associate with keys. And you can have a very complex key structure that relates to your data store's values. So you send a key to the Redis, and it returns back different types of data primitives. For example, you can request a set of objects. So if I say, okay, I want to get a listing of students that are in my class, and I want it to be unique, and I don't want to have any duplicates, then you could create a set structure in Redis, and then every object will be guaranteed unique. And so when you request that key, you'll get back this set of unique members. There's also a sorted set, which you can do some cool things with. There's simple strings, and there's also sort of a hash table function. So there you can actually, it's a sort of a key value with key values, if you will, which allows you to do a lot of stuff. So what I have done at Colorado College is that we have created 4 different Redis instances for each of the MARC-R entities. So we have our own work Redis instance, our instance Redis instance, our authority instance, and our annotation instance. And those keys within those data stores can refer to each other. So, for example, the instance can refer to an associated work, for example, as well as the work can refer to all of its instances. Also, the authority can be associated, like the creator can be associated with the work. And so we have this all kind of built-in association. And it really lends itself well to the entity relationship model of Ferber, as well as the linked data approach of MarkR. So here, so this is our MarkR data stores are actually in production. We have it supporting our discovery layer, which is also an open source product. And what we've done is we've ingested all of our MARC records. Currently, CC has over 860 MARC records. And when it's ingested, the structure can be different for each of these. So you can see for just 860 in our work data store, we have over 3 million distinct keys. Now, some of those keys are really to support sort of a title search app that I've got going, that we have available. So that's kind of exploded more. Those instances, since the title is not associated with an instance, we don't have to replicate all those different data structures. That's why we have almost 1 million less, or more than 1 million less keys. You can see, even with the authority, we have 1.5 million. So each of the creators, each of the authors in our MARC records has at least one key entry in our authority data store. In fact, there's probably a couple per creator. So Redis is very fast, and it's has a very small footprint, and you can see it's very efficient. So it's like 1.2 gig is the size of our MARC records, all in total, when we download the large MARC record. When we ingest it into the Redis, all of the works that represent the works in the MARC records, that comes to less than 662 megabytes. So we're able to put in a lot more entities within that. So we're able to store our bibliographic records in this new sort of model using MarkR, using NoSQL. The kind of the front-end interface, we have a couple of different techniques. First thing is that we've taken the approach to, instead of creating a full web page to interact with the data store, we've been working on these small, self-contained HTML5 apps that are really meant to be usable on any type of form factor. And we're using Bootstrap and HTML5 and a technique called responsive development that adjusts the sizes of these apps depending on the form factor of the device that's accessing it. The actual web development side, the web framework, we're using Django, which is a Python open source development that's pretty popular. And putting it all together, this is sort of what it looks like. So we have each of the instances, the Django Aristotle apps. The Aristotle library apps is the name of the project. And those, the app environment connects to all the different MarkR data stores. We also have an operational instance to support non-bibliographic information, for example. And then we have this Sentinel instance, which allows us to monitor all these different Redis instances. So, going down, and finally, so where are we going with this? Well, this whole environment is really lends itself to scaling up, because MARC is being used, or Redis is being used by like Stack Overflow, used by Craigslist to manage their millions and millions of objects. Redis should be able to easily handle a consortium level of records. So the Colorado Alliance of Research Libraries and has agreed to collaborate with us to see if we can roll this out for a consortium-wide data store. And what this is going to look like So we're part of what we're doing is looking at some grants and things like that, and this will be a multi-year project. And really, oh, sorry, pulling through this as quickly as I can. So this is kind of a visualization of what this consortium level Redis data store will look like. So the idea is that if the instances of each institution will be either hosted locally within that institution, or if the institution is small, there's no reason they couldn't host their own instances on like Rackspace or Amazon. So they can use the public cloud for their own, or they can run it on their own infrastructure. So they would be responsible and have full control over their own instances and also on their authorities, as well as their own annotations. Then what the Alliance does, we'll have these master work entities, or work data store, that is then tied in, that is kind of fed automatically into the instances and into the apps. So for the end user, their apps, it's going to be seamless. It doesn't really care where they're pulling the data, whether it's from the consortium, whether it's from the individual instances. So that's really broadly what I'm working on this next year. We're hoping by next spring to actually have a demo of this for the entire consortium. And since DU is a part of that, DU is probably going to be a partner in this. And so it's pretty exciting. And I'm sorry I didn't give you enough time for questions, but thank you. Thanks.